Namaskar, friends. Now I'm Birajdar Krishna and I'm in quality improvement in math education project. My video-based PP presentation 2019 and 20, and my topic of presentation is quadrilateral, and registration number is MTF080. My school name is Jilla Parishad High School, Vishnupuri, Taluka and District Nanded. My topic of description is rhombus. And this whole project is guided by our Professor I.K. Rana and Professor S.T. Garpure, IIT Bombay. Now, I'm going to present my topic, that's a quadrilateral. Here is a quadrilateral have topic, that's a subtopic name is a rhombus, and I'm now presenting that's a rhombus. What's a rhombus? And that's all about I'm talking to show the rhombus. Here is a rhombus is a quadrilateral. Now, first of all, observe and explore. I have a task one. Observe the pictures carefully. Here is the first figure that is properly we observe on the ground. It's a net, volleyball net. And second we play, that's an indoor game, that's a chess board. Observe this. Then again we see the day-to-day life examples which have different shape and size. This is the particularly that indication board. That's a one way, two way. On the road you see these symbols. The second have this a big picture of the buildings on the top view, how it looks, that's are shown in this picture. Then again, these are the ornaments, ear ornaments, earrings are in this. Particularly have shapes this. Again, these are the side mirrors of vehicles. Again, in a short pictures here, here is a air, here is a instrument that's of used by masons, kite, playing cards. Then have again these ear ornaments, the design on the sweater. Then there is a picture. These are again rings and rings that's used for particularly functions, or these are the ornaments, hand ornaments. Again these are earrings. These are left of again these symbols, note on all these figures. This is a bag. From these all figures, we observe that they are different size and shape. We all know the Indian sweets also. On the occasion of festival, we make different sweets. Which are those sweets have shapes like quadrilaterals? Yes, you know, particularly Kaju Katli, Shankar Pali. These are Barfi. These are very famous sweets in India, and they have a particular shape as like a quadrilateral. These are the examples are there. From the observation, some portions I put forth in front of our students. What do we observe in the above figure? We can see the different quadrilateral shapes. They have the all four edges figure, but they have the different size and shape. They are not like the same one. Are these all quadrilaterals have same size and shape? No, they have a different size and shape. Means some figures, some have all sides equal, some are not equal, some opposite sides are parallel, some are not parallel. In this way, you may see that the different quadrilaterals have different size and shape. What are the daily life objects having different quadrilateral shapes? You know, in our day-to-day life, it can be found in a variety of things around us, such as a kite, window of a car, rhombus-shaped earrings, that's ornament, structure of a building, mirrors, and a section of baseball field or a chess field. You know, that's a chessboard again have a shape like this, quadrilateral. So many things are there. They have a shape as like a quadrilateral. Then, which are those articles and objects in above figures have equal edges? Above those figures we observed here, and which have the same equal edges. The quadrilaterals in net, you found that the net have quadrilaterals and all their edges are same. Signal mark, those on the red roadway, we say that it shows the direction of the road. Again, they have the all edges same. Earring ornaments also have the all edges equal. Finger rings, baseball field tiles, that's shown. These are all have the equal edges. The next question for us: how many angles does quadrilateral have? Quadri means four. You know it has a four angles from this. This one is a first one, second, third, and fourth. In this way, you know they have four angles. Now, moving to the second question, define and prove. From the observation, now we are defining different quadrilaterals have different properties. First of all, you have described what is a quadrilateral, and then quadrilaterals have different size and shape, and from that, different quadrilaterals have different property. Quadrilateral having all sides equal is called a rhombus. The quadrilateral, particularly whose all its edges are equal, that's rhombus, and we are going to learn about it. A rhombus is a parallelogram with four sides equal and opposite angles are equal. That is the property of rhombus. It is a parallelogram. What's a parallelogram? Whose opposite pair of sides are parallel, with having additional property that all the four sides of parallelogram are equal and opposite angles are equal. That is a rhombus. Then properties of rhombus: opposite angles are equal. This angle is congruent with this angle, and again this angle is congruent with this angle. The diagonals are perpendicular bisector of each other, means they make right angle with there, and these two segments are equal, and these two segments are equal, and adjacent angles are supplementary. This angle is adjacent with this angle with this angle with this angle with this. In this way, the adjacent angle have some that's a 180 degree. That is, adjacent angles are supplementary. Some particular condition for rectangle and parallelogram: if adjacent sides of a parallelogram are equal, then it becomes a rhombus. This is a parallelogram, let's consider, and if their adjacent sides are equal. If it is a parallelogram, then the property of parallelogram says that their opposite sides are equal and opposite angles are equal again. And if the parallelogram have adjacent side equals, means this side equals this, then all sides become equals. That's why if adjacent pair of sides is equal in parallelogram, then it becomes a rhombus. If the diagonals of perpendicular of a rectangle are perpendicular bisector of each other, then it also behaves a rhombus. How's it? The diagonals of rectangle are already they are bisect each other and they are congruent. And if they are making right angle, then all the four sides becomes equal. That's why all the four triangles formed by these diagonals get equal, and that's why this rectangle becomes a rhombus. Now apply and evaluate. What's in the apply and evaluate? Question number 1. The perimeter of a rhombus is 120 centimeter and one of its diagonal has length of 40 centimeter. Find the area of rhombus. This is a rhombus. A, B, C and D. This one is a rhombus, and this is O is a point of intersection of the diagonal AC and diagonal BD. The sum of all sides means that's four side sum is 120. That's why perimeter of rhombus equals to 4 into side, because all four sides are equal. 120 equals to 4 into side, therefore side, this 4 goes to left and 120 divided by 4, side equals to 30. And this diagonal makes 4 right angle triangles, and therefore to find the side of the rhombus, I will take AOB as a right angle triangle. In this right angle, AB square equals to AO square plus BO square. The whole length is of one of the diagonal is 40. If I take half of it, diagonal by 2, D by 2 means these two segments are equal. AB equals OC, and that is side square equals to diagonal 1 square upon plus diagonal second diagonal by 2 square. Half of the first diagonal square plus half of the second diagonal square. That's why 30 square equals to 40 by 2 square plus D by 2 square. That's a diagonal number 2 square. That's putting the value 900 equals to 400 plus D by 2 square. Solving that, 900 minus 400 equals to D by 2 square. 500 equals to D by 2 square. That D square by 4, and that 4 goes to that side. This side D by 2 equals to, and from this taking square root on both sides, we have found that the square root of 500 is, that's a 10 root 5, d by 2 equals to 10 root 5, d equals to 20 root 5. And you know the area of the rhombus 1 by 2 into product of the diagonal 1 into diagonal 2, 1 by 2 40 into 20 root 5. That's here 2 get cancelled, 20 into 20, that's a 400 root 5 centimeter square is the area of the rhombus. Now the second question is, if the area of a rhombus is 2400 centimeter square and perimeter is 200 centimeter, then find all possible pairs of diagonals of rhombus. It's very interesting question. The area of a rhombus is given there. From the perimeter we have find your side. Perimeter equals to 4 into side. That's why 200 equals to 4 into side. Therefore side equals to this 4 divides 200, then side equals to 50 centimeter. And therefore you know the diagonal makes 4 right angle triangles. Again there side square equals to diagonal 1 upon diagonal d1 upon 2 square plus d2 upon 2 square. Keeping the values here, side square is a 50 square equals to d1 square plus d2 square. They have the both denominator same, that goes to the left and multiply with the square, that's a 2500 into 4, that d1 square plus d2 square equals to, that's a 10,000. Now we want to find the all possible pairs of diagonals of rhombus. We have addition there, area of rhombus equals to 1 by 2 into d1 into d2. From that the product of d1 d2 equals to 4800. By putting the values of area we get the product of, you know the d1 plus d2 square equals to d1 square plus d2 square plus 2 times of d1 d2, and from that you know d1 plus d2 whole square equals to 19600. Taking square root on both sides, that is d1 plus d2 equals to 40 from 2 and 3, and there is a d1 and d2 whose product is 4800 and sum is 140. Then it is possible that d1 equals 80 and d2 equals to 60 centimeter is the only pair of diagonals. That's the pair of diagonals whose area is 4800 square centimeter square. And in this way we have found the possible pairs. Then question number 3, one of the diagonals of rhombus is equal to a side of a rhombus, then find the angles of rhombus. Very interesting question. These diagonals have equals to the side of a rhombus, then it becomes equilateral triangle. And what happens if this is an equilateral triangle? Find the angle of the rhombus, that means this angle is 60, this angle is 60, and opposite angles are equal, that's why this 60, it's a parallelogram, and therefore this 60, again these are alternate angle, this 60, this 60, that's these two angles are 120 120, and these are angles are 60 60. In the diagonals and sides are equal, it become equilateral. This angle makes equilateral, therefore all angles are each is 60. Then two angles of measures are 60 each and two are of 120. These two are the 60 measure and these two are get the 120 measure. There is that. Then I move to the next question. The size of the obtuse angle of a rhombus is twice the size of its acute angle. The side length of the rhombus is equal to 10 centimeter. Find the area of rhombus. Very interesting question. Now if you make the rhombus and what is there, the size of the obtuse angle of a rhombus is twice the size of its acute angle. One angle is a acute, one angle is an obtuse, and then from there you know if the side is 10, then by using the property of 30 60 90 degree triangle, the diagonals bisect each other, therefore the diagonal makes the 30 60 90 degree triangle, and from that you know the hypotenuse, the rhombus side is, that's the side length is 10, means you get the uh, length, that is hypotenuse of 30 60 90 degree triangle. From that we get the values of other two sides, and from that you get the diagonal length, and we can easily find the area of rhombus by using the formula of area of rhombus. And then thank you for that being such a operation.